Let's get started. So today I'm going to go over this search to the matrix problem. You're given a matrix M by N matrix, integer matrix, with the following two properties. Each row is sorted in non-decreasing order. In other words, is increasing order, is in ascending order. The second rule is that the first integer of each row is greater than the last integer of the previous row. So in other words, the first column is also sorted in ascending order. So given an integer target, the target value return true if the target is in the matrix, or false otherwise. We must write that O of log m times n time complexity m. Yeah, so that is the problem. So as we can see, we got the input to the array, integer array, and a target value. And the output is 0 or 1, true or false. Oh, yeah. So whether the target value is existed in the matrix. And the constraint is that each row is in ascending order. The first column is in ascending order. So we have two rules, two properties that kind of tell you that the matrix is sorted in some way. So, and also the constraint that we need to write a solution with all of log m times n time. So which means we need to use binary search. Use binary search twice. And so the first binary search would be the column. So we find out which row we should search from. So for example, the target value here is 3. So after look at the first column, we will choose the first row and then search for the target value in that row. So it is very straightforward. So let's jump. So first thing is use binary search for the first column. Decide which row should we continue to search. And the second step is to search the row for target value. So there are two binary search, but it's somewhat different because from the first search, you may not like the first search you return an index of the row you need to search, and the second binary search you return true or false. So it's a little bit different. So I will try to do it by two functions. So search column. So I will search column first. So this is traditional and left and right pointer. -1, and then while left is less or equal than right. Calculate the mid. plus right. If y divided by 2, so if nums mid is less than target, if nums mid is less than target, so left is equal to mid plus 1. Else if nums mid is greater than target, right equals to mid minus 1. Yeah. So else return mid. So after I finish the while loop, the left is greater than right, but we need to find the we find the row that we should search from. So we should choose the right pointer to return. And so let's go to the second search row. So for this search row, we need to return true or false. So it's pretty much the same, but I need to do a little bit modification. So just copy that and so I'm going to return 1 because you hit the target value. So if you break out the loop and you just return 0 or return 2, return false. So so I can simply copy that and run the codes. So I put it here. My God. After these two functions, I can do like column is equal to search column something target value. So I need the first column of the matrix. So I would say matrix I 0 for I in range length of a matrix. And then return search row. And then I'll just put in matrix column and then target. And yeah, it runs. And so yeah, so this method actually so two binary search, each one, the first is O log M, and the next the time complexity will be O log N. When you add them together, it's O log M times N. And yeah, that's it.